Alrighty. So let me just move this out of the way. There we go. That'll be even better. Make it a little bit smaller so it's not blocking. There we go. Excellent. Okay, hopefully you can see the screens, and the one that you can see at the moment is the heart, lungs, and muscles. And this is a very, very quick recap of essentially the first 6 to 8 weeks of year 11 PE. We don't need to be able to label the diagram. We don't need to know about the actin and the myosin and that deep level right now. What we need to know is that a reminder that the heart pumps blood to the lungs, and that blood carries carbon dioxide. The carbon dioxide goes into the lungs to be breathed out, and the oxygen that was breathed in is put back into the bloodstream. It's taken back to the heart so that the heart can pump it to the muscles. And we spoke about that last year, but we didn't actually talk about exactly why that oxygen was required at the muscles. Well, now you know why the oxygen's required at the muscles, because of the aerobic system. And a reminder as well that the aerobic system produces carbon dioxide. And so that's where the carbon dioxide's coming from, those muscles, when it goes back to the heart and then back to the lungs to be breathed out. So heart, lungs, heart, muscles, that's the pathway that the blood is actually taking. And that's the pathway that the oxygen and carbon dioxide are traveling for that purpose. Okay, so very, very quick introduction or reminder of where we're at. On the SAC next week, you do have to refer to acute responses when you're talking about the energy systems, okay? However, Mr. Smith and I know how difficult it is right now with a short time period between now and the SAC to actually go through the whole thing, okay? So what we've done is we've just picked the most important aspects and the ones that you should actually already know from year 11 PE, and we're just going to refresh your memory with them. So, acute responses, what are they? They are changes that happen inside your body during exercise and during the recovery from exercise. The word acute means short or small, so they're short-term changes, okay? So the short-term changes that happen to your body during exercise and during the recovery from that exercise bout. Acute responses are actually down under 3 different categories. So the first one is the respiratory system, the second one is the cardiovascular, and the third one is the muscular system, which was how we actually broke down year 11 PE in teaching you all 3 of those and all 3 of those systems in the body. So remember, respiratory is all about oxygen, breathing, lungs, and the pathways to get oxygen and air in and out of your body. And there were 3 key elements in the respiratory system that we discussed last year. The first one was ventilation, and ventilation is made up of tidal volume and respiratory rate. Let me just put this in very, very simple terms. Respiratory rate, how quickly you are breathing. How many breaths per minute? Tidal volume, what is the depth of each individual breath? Is it a big, deep gasp of air, or is it a short, shallow breath of air? When you multiply how big the breath was by how many breaths per minute, you end up with how much air am I getting into the body per minute? And that's ventilation. And if I was to say to any single one of you, what do you think is going to happen to ventilation, tidal volume, and respiratory rate during exercise? I know every single one of you are intelligent enough to tell me they're going to increase. And if I said to you, why are they going to increase? The answer is because we want the body to be in the aerobic system, because the aerobic system doesn't have fatiguing byproducts and it can last for the longest period of time. So that makes sense as to why ventilation will increase, tidal volume will increase, and respiratory rate will all increase during exercise. How much do they increase? This table's a pretty good one. So it says to us just the average person, and some people will have more or less. The average person during rest will breathe about 12 times per minute, okay? 12 times per minute with 0.5 litres per breath. Multiply that out together, litres per minute, we've got it over there. When we start to do moderate level intensity exercise, the number of breaths per minute will go up to 30 or around about. It's different from person to person. This is just an indication. And the depth of each breath is actually going to bring in 2.5 litres of air rather than 0.5. So that multiplication becomes much, much larger. And then you'll notice that during maximum exercise, it continues to increase on both categories, and therefore there is a large increase for ventilation. Okay. I don't think that you guys will need to remember any of those numbers at all. All you need to know is what is ventilation, what is tidal volume, what is respiratory rate, which we should have remembered from last year, and just refresh your memory now. But the fact that they all increase to bring more oxygen into the body and get more carbon dioxide out of the body during exercise so the body can get to the aerobic system. I'm feeling pretty confident, I would think, in all of you guys, maybe right now going, I've just remembered those words, but within a day or so of going back and remembering those words time and time again, this will all make a lot of sense to you, especially the fact that the oxygen's increasing. Don't worry too much about the plateauing part and why things are leveling out. At this stage, we're not going into that depth because we're too close to SAC 2. We're just talking about them increasing. Happy to move on, and I'll take any questions at the end, to the cardiovascular. Now, a reminder that the cardiovascular system is about the heart, the blood, and the blood vessels, okay? So anything that's happening to the heart, blood, and blood vessels. Now, there's a lot of things that happen to the cardiovascular system that we're not going to discuss before the SAC. We'll cover that after the SAC, and they won't be questioned on the SAC. But the three most important ones share the same relationship as what we just discussed for the respiratory rates and changes. So cardiac output, that is a product of stroke volume multiplied by heart rate. Let's break this down pretty simply. Heart rate, we should all know. How many beats per minute that your heart is pumping blood around the body. Stroke volume is the amount of blood moved out of the heart every single beat. So every time the heart squeezes, the amount of liters of blood that is pushed out, that is the stroke volume. And then if we multiply those two together, the same as with ventilation, we end up with this thing called cardiac output. And for some reason, they decided to call it Q. But essentially, how much blood is being pumped around the body per minute. What you guys can probably assume is this. If my lungs are bringing more oxygen in, I'm actually managing to get more air in because I'm breathing faster, respiratory rate. I'm getting more air in because I'm breathing deeper, tidal volume, therefore my ventilation is larger. If that's happening and that's all increasing, but the heart is not keeping up with increasing as well, then the muscles won't be getting it. So if the heart increases its number of beats per minute, and with every single one of those beats, it pushes more blood out, then overall that cardiac output is going to have to increase, and it's going to have to increase by quite a lot, similar to ventilation. And what we can probably understand now is more air and oxygen's coming in, more blood's pumping around the body. What do we think is going to happen at the muscle site? More oxygen at the muscle site, more removal of carbon dioxide. The body can get into the aerobic system a little bit easier. So you can see here, there is a massive difference between trained and untrained athletes, okay? I will give you a hint that on the SAC, you guys will be comparing your data or data that we give you for those people who were unable to get their data from the run against an elite athlete who has run the same distance of 1,500 meters. And so this table here could be a key to why they are able to complete the run faster than what you're able to complete the run, okay? Same thing, you can look at what's increasing and why they're increasing, but essentially, if you've understood what I meant about the respiratory system, you should be able to understand the cardiovascular system, okay? The last thing I want to show you is this table here at the bottom of page 157 and explain to you what you need to know about the muscular system. Now, in terms of the muscular system over here, we decided, Mr. Smith and I, and we'll let you know now, that in terms of the muscular system, there's a lot of intricacies about what's happening there. So you guys are going to be able to choose which of those changes you want to focus on for the SAC itself. Okay. So you guys do not have to use the ones that we're going to give you whatsoever. You can choose your own ones. But if we have a look at some of these, it's pretty straightforward. During exercise, the amount of lactate in the muscle is going to increase. During exercise, this one here says intramuscular substrate levels. That's just talking about fuel levels. ATP, it's going to decrease. Creatine phosphate, it's going to decrease. The amount of glycogen in the muscles, decrease. The amount of triglycerides, decrease. We know one of the byproducts of the aerobic system is heat. So the temperature inside the muscles and the body will increase. The amount of blood getting to the muscles is going to increase. And all the way back from year 11, we're actually asking for more muscle fibers to contract in comparison to during rest. So they're all very, very straightforward changes that happen during exercise. And you're going to need to know 3 of them. You pick the 3. Here's the key though. Are those muscular acute responses changing because we're in aerobic energy systems, or are they changing because we're in anaerobic energy systems? I'll give you a hint. If you were to pick something like the lactate production, but you are running at sub-maximal, so 40, 50% of your maximum heart rate, that's not going to be a major change. But if you're going for a 1,500 meter as fast as you can run, there's going to be a large amount of lactate produced in your muscles. So that might be a good one to select for the run that you've been asked to do. Okay. So you guys can think about what works in the situation that we are giving you. Okay. So what works in the situation of the, let's get rid of this, stop share. So what's going to work for an aerobic run? What's going to work for an anaerobic run? Okay. Is it going to be changes in the muscular system like lactate, or is it going to be changes like increased heat? So you need to start thinking about when you did or are going to do your 1,500 meter run, were you dominant in your aerobic system? Were you dominant in your anaerobic system? Were you dominant in phosphate creatine? That's totally up to you. I can't give you the answers to that SAC. One thing you do know about the SAC is that it's all focused around the data from the 1,500 meter run. So I'm going onto Compass now in the background. I'm going into resources, and under term 2, there is a folder that is now being unlocked for you. And that folder is called SAC preparation. There is a what you need to know sheet. There are 2 practice SACs, and there is a practice SAC response guide, which is in the form of a PowerPoint. The first slide of that PowerPoint gives you some major hints towards the SAC. And when I say major hints, we know that the SAC has to be using data from a lab. The data is a 1,500 meter run. So if you need to talk about the interplay, the fuels, the fatigue, the energy systems, it's all going to be based around a 1,500 meter run. So you can actually spend some time between now and the SAC next week in just really focusing on the 1,500 meter run, asking me some really specific questions. I just can't give you the answer now. So you've got plenty and plenty of stuff to do, okay? Practice SACs are there, peak performance is there, Ed Roller is there, and I'm going to stay on this Zoom for anybody who has any questions about any of that stuff for the remainder of this lesson, okay? Otherwise, if you feel comfortable with what I just refreshed your memory on and gave you some reasons as to why those changes are taking place, you are absolutely free as a bird to go and complete whatever it is you need to do.
Sweet.